Okay, so this is the second part of Unit 2, Measurements and Calculations. So let's talk about significant figures. In math, if we're doing some kind of calculation, it's not a big deal how many digits we keep because we just do the calculation. But in chemistry, what we're doing is we're using math in an applied way. It represents something that we've measured. And your measurement is only as precise as the device that you use to measure it. When we measure something, we always want to read as many decimal places as possible and then estimate one more, or as so if we're looking, for example, at this ruler, or we're trying to measure this pencil, we look at the bottom ruler and we can see that the pencil lies somewhere to the right of 7. So we estimate our first decimal point, so it's not quite 7.5, so probably we could say 7.3 or 7.4, something like that. If we use the top scale, you can see that we have there's more precision, there's a lot more points that we can use. And so if we're looking at the top scale, we can see that actually the pencil is somewhere between 7.3 and 7.4. And so we're going to actually estimate one more digit, and it looks like it's maybe a little past 7.3, so we might say 7.35. We might say 7.36. I guess it depends on the mood you're in when you're reading it. But the idea is that you always have one digit of uncertainty that represents the estimate. Okay. So let's look at this example. We know that to find the area of a square, we multiply the length times the width. So in this case, if we know the length of one side and we don't know the width, but we know the area, what would we do? We would divide. So we could find the length of the other side by taking 43.6 and dividing it by 9.3. Well, if you put that in your calculator, here's the answer you get, 4.688172043. Well, that's a perfectly nice number in math. However, in chemistry, most of those digits are pretty meaningless to us. How could we know that the measurement is that accurate to that many decimal points? And so we don't really want to report that number. We want to round it to give us a little bit more information as far as significant figures. So if you notice, our original numbers only had one decimal place. So in this case, I would want to round my answer to one decimal place because it indicates the same significance, that we were able to use a ruler where we could estimate one decimal place. So like I said, the 4.688172043 doesn't really make sense in terms of this problem because we can't measure it that precisely. So I would report an answer of 4.7 in this case. And that's what significant figures are. There's actually quite a lot of very detailed rules about how to report a number using significant figures. And if you ever go on and take more chemistry, you're going to have to learn those and deal with them. But for this class, you can I just want you to be aware of it. I don't want you to write that whole long number down. I want you to estimate it. If you had probably rounded it to 2 decimal places, it'd be all right. You don't want to over round and you don't want to under round, and so some of it's just going to be a little bit of common sense. Usually you can round something to the same decimal place, although as you'll see, that doesn't always work. But I just want you to be aware of what it means to be significant. So this is what I just said. There's a number of complicated rules, and in general, here's what you can do. Report the same number of decimal places with your answer, or kind of common sense. I'm not going to take points off if you don't do it exactly right, but you do want to have some sense of rounding. So let's just review the rules for rounding numbers. You want to decide which is the last digit that you want to keep. and then look at the digit following the last one. If the digit following the last one is less than 5, then all you need to do is drop everything after the digit that you want to keep. If the digit is 5 or greater, you need to increase the digit you're keeping by 1 and then drop all the ones after it. So you're rounding up. Don't forget to do that. A lot of students forget to round up. They'll just cut it off. So if we look at the examples, round 10.825 to 1 decimal place, the first decimal place is the 8. That's the one we want to keep. So we look at the next digit, which is a 2. Since 2 is less than 5, we drop everything after the 8, and our rounded answer is 10.8. Okay, round 0.5175 to 2 decimal places. Well, in this case, the 1 is the second decimal place, and that's the one we want to keep. So we look at the digit after, which is a 7. Since 7 is greater than 5, then we round up, and so our answer would be 0.52. There are some numbers that have no uncertainty involved with them, and we call these exact numbers. Exact numbers are those where uncertainty is not present, and so we don't have to worry about the rounding them or about significant figures or about how to count them. So some of these examples are if we've got a defined relationship. So for example, 100 centimeters in a meter, it doesn't matter how many decimals we use. We could say 100.000000 centimeters equals 1 meter. It's part of a definition, so there are no significant figures because there is no uncertainty. Same thing with a counting number, like a dozen eggs means 12. There's no uncertainty there, it is just 12. And then again, a reduced simple fraction is also an exact number. All right, so the rest of this unit, most of the rest of this unit is going to be dealing with converting units. So, you know, I don't want to go too fast, but you might want to stop and re-listen to some of this. Converting units is an important thing to be able to do, and so I'm going to go through how we do that. So, for example, it's something you already do in your head. If I asked you how many inches are in 2 feet, you would very quickly say 24 inches. So what is it that you did? Well, you know you multiplied by 12. Why did you multiply by 12? Well, you know there's 12 inches in a foot. That one's a pretty straightforward, you know, we grow up with that and pretty straightforward, but we know there's 12 inches in a foot, so how did you know to multiply by 12 and not divide by 12? Sometimes it's a little bit confusing what to do if you're not exactly sure, but using conversion factors or the process that we're going to be doing here will always help you get the right answer, because what you do is line up your units. So 12 inches to 1 foot is called a conversion factor because these are two things that are equivalent to each other. They're equal to each other, just with different units. So we can write a conversion factor, which is basically a fraction that has the two things that are equal to each other, one in the numerator and one in the denominator. So for example, since 1 foot equals 12 inches, we can write it as a fraction, 1 foot divided by 12 inches, or we can write 12 inches over 1 foot. The one that you're going to use will depend on which way you're converting, from feet to inches or inches to feet. What you're trying to do is get the unit that you're looking for to be on the top, and the unit that you already know to be on the bottom. So why can we do that? Well, since the numerator and denominator are equal to each other, then that fraction is actually equal to the number 1. And if you multiply anything by the number 1, what do you get back? You get back the original answer. Now in this case, it's just that the original answer will look different from the final answer because they're in different units, but you know that they're equal to each other. And so any number multiplied by a conversion factor will give an answer that is equivalent to the first answer, but in new units. So they're equal to each other, they just might look a little bit different. So let's go through the process to convert 2 feet to inches. The first thing you want to do is put down what you know. Then you're going to multiply by a conversion factor. Again, you want to put the units you're trying to get rid of on the bottom and the units you are trying to find on top. Complete the calculation by multiplying everything in the numerator and dividing by everything in the denominator. So here we have 2 feet. We multiply by our conversion factor. Since we're looking for inches, we put inches on the top, feet on the bottom. 2 times 12 divided by 1 is 24 inches. Notice that the units will cancel in a fraction because 2 feet is in the numerator. If you get confused, you can put 2 feet over 1 because it's really, any fraction. You can make any fraction by putting it over 1 if that helps you see it better. But we have feet in the numerator, and then we have 1 foot in the denominator, and so they cancel out. And so the units that we're left over with is inches. Since we're using units or labels to help us get through the process, we sometimes will call it the factor label method. Sometimes you'll also hear it called dimensional analysis. So here are some of the common conversion factors that you may need to use in the class, or that you've already probably used if you're looking at the English to English conversions. And just for your information, I have this as a handout that you can find in the folder under Unit 2 on Blackboard. I also have the metric ladder and the metric table that you can also print out if you want to. But some of the conversion factors, you can see we have English to English, which you're probably familiar with. Length, 12 inches equals 1 foot, 1 yard equals 3 feet, 1 mile equals 5,280 feet. Then if you're trying to convert from English to metric or metric to English, you can see the ones in the center. And then I've also put some of the most common metric to metric conversions on here as well, although you can also use your metric ladder or your metric table for that. So here's the method, the step-by-step what we do. First, write down what you know and include both the numerical value and the units. It's a really good habit to be able to use your units all the time. Leave some working space, and you want to then come up with a quantity, a factor that are 2 things that are equal to each other. Make sure that you put the units of the quantity you already know on the bottom so they cancel, and the units that you're trying to find on the top. And then after you have these, you do all the arithmetic to produce the final answer. So multiply by anything in the numerator, divide by anything in the denominator. All right, so let's do an example. How much does a ball weigh in kilograms if it is 3.41 pounds? So put down what you know, 3.41 pounds. And then next you want to find a conversion factor that relates pounds to kilograms. So if we look on our conversion factor sheet, we know that 2.2 pounds equals 1 kilogram. So now we want to use the conversion factor, and we want to make sure that pounds goes in the denominator because that's what we're trying to get rid of, and kilograms goes in the numerator because that's the unit we're trying to find. Do the math. 3.41 times 1 divided by 2.2 gives me 1.55. And then make sure, cancel your unit. So now you know that your answer will be in kilograms, and make sure and put your units, report them. It's really important to always label your answers with the units. How much does that ball from the last example weigh in grams? Well, again, put down what you know, 1.55 kilograms. One thing you could do actually is use the metric ladder. So you could move the decimal over 3 places to the right to go from kilo to the basic unit. Also, you know that there's 1,000 grams in a kilogram, and so that could also be used as a conversion factor. We're looking for grams, so that goes on the top. Kilograms goes on the bottom. Do the math, and that would be 1,550 grams. All right, this one shows you that sometimes you don't have a direct conversion factor, but if you can find more than one conversion factor to get where you're going, you can do them in turn. All right, so let's say your desk measures 3.35 feet and you want to know how many centimeters that is. Well, if you look back at the conversion factor. Now you could probably Google feet to centimeters and find one single conversion factor, but if you only had that sheet in front of you, how would you do it? Well, we do know that there's a conversion factor from centimeters to inches. 2.54 centimeters equal 1 inch. I believe there's also another conversion factor that will take you from feet to meters. And so you could actually do it either way. But let's look at this. 2.54 centimeters equals 1 inch. Well, we don't know our we don't know our measurement in inches. So we can't convert to centimeters because we don't know our unit in inches. But we do know how to convert from feet to inches. We've just done that. We know that there's 12 inches in a foot. So what I'm going to do is take my 3.35 feet, convert that first to inches. So there's 12 inches per 1 foot, put the feet on the bottom, the inches on top, and so 3.35 feet is the same as 40.20 inches. Now we know a conversion factor that will take us from inches to centimeters, so we'll start with what we're given, 40.20 inches, and now we multiply by 2.54 centimeters in the numerator and divide by 1 inch in the denominator to get 102.11 centimeters. If you get really good at it, you don't have to do the calculation right in the middle. You can, take 3.35 and then multiply by 12, multiply by 2.54, set that up all in one. But most people in this class like to do them in separate calculations. One thing that I would recommend is if you do the first calculation and you get a really long decimal place, don't round it at that point. If you know you're going to do another calculation, just leave the calculation in your calculator and then do the next calculation and then round at the end. Because otherwise what you get is something called rounding errors, and so your number might be slightly different from someone else's. Just in case you were wanting to do, you might have noticed a different way to do that. So if you're looking at the conversion factor, you might have noticed that there is 1 foot equals 0.3048 meters. So you're saying, okay, I've got 3.35 feet. Let me convert that to meters. You could do that by using the 0.3048 meters in the numerator and 1 foot in the denominator, and you could convert that to meters, which would be 1.02 meters, and then you can convert using the metric ladder from meters to centimeters, or knowing that you have 100 centimeters in a meter. So there are more than one right answer or one right way to do these problems. You might see a different way to do it than your neighbor or your someone you're working with, and it's fine. And you might get slightly different answers. Someone might get 102.2 and someone might get 102.1, but usually that just has to do with rounding error, and that's perfectly fine. All right, so let's just look. These are some for you to do, but let's just work through it. If we want to convert 42.6 kilograms to pounds, how do we do that? Well, like we saw earlier, we have a conversion factor. 1 kilogram equals 2.2 pounds. And so if we start with 42.6 kilograms, then we put 1 kilogram in the denominator and 2.2 pounds in the numerator, and so then we get the answer of 93.7 pounds. The second one is also fairly straightforward, because if we look on our conversion table, we can find that 2.54 centimeters equals 1 inch. So if we start with 34 inches, we put the inches on the bottom, 1 inch on the bottom, 2.54 centimeters in the numerator. Do the calculation. 34 times 2.54 divided by 1 will give us 86 centimeters. The third one's a little more difficult because we won't find a conversion factor directly from kilometers to feet. We do know that there's a conversion from feet to meters. There's also a conversion from miles to feet or kilometers to miles. So there's a couple of different ways you can do it. The way I have it here is I first converted from kilometers to meters, since there's 1,000 meters in a kilometer, so 37,200 meters, and then I used my conversion factor that there's 0.3048 meters in a foot, and so if you divide, you end up with 122,000 feet. If you had converted from kilometers to miles first, using that conversion, then miles to feet, you should have gotten very close to the same answer. Okay, sometimes we get a little bit more complicated, and there's a unit in the denominator that we want to convert. The thing here is to keep the new units on the bottom. So if we want per deciliter or per liter and whatever we want per, we want that in the denominator. And so we're actually going to do the opposite of what we've been saying. If we want to get rid of a unit in the denominator, then we have that unit in our conversion factor in the numerator, and then the unit that we want to be in the denominator in the denominator. So it's a little bit backwards. So for example, during a glucose tolerance test, the serum glucose was found to be 135 milligrams per deciliter, and we want to convert this to grams per liter. What I would do is convert each of them separately. So the first thing I did was I converted the milligrams to grams. So 135 milligrams, then I multiplied by 1 gram divided by 1,000 milligrams to give me 0.135 grams per deciliter. Remember also that if you've got a per unit, that it assumes that it's 1, even though it doesn't have it in there, it assumes that's 1. So 135 milligrams per deciliter means 135 milligrams per 1 deciliter. So if I've done the conversion where I've canceled out milligrams to get grams on the numerator, now my unit is grams per deciliter. So the second conversion converts deciliters to liters. Now notice that this time, because deciliters should be in the denominator, I'm going to put the deciliters in my conversion factor in the numerator, 10 deciliters, and the unit that I want to get in my denominator, 1 liter, put that in the numerator. So now again we have a deciliter in the denominator, a deciliter in the numerator. They can cancel, and then we end up with grams per liter. Another way that you could do this problem, if you wanted to, is you could separate the two units away from each other to start with. So you could take 135 milligrams, convert that to grams. 135 divided by 1,000 will give me 0.135 grams. And then I could take deciliters. 1 deciliter is the same as 1 deciliter is the same as 0.1 liters, or there's 10 deciliters in a liter. So 1 deciliter would equal 0.1 liters. And so then we could take the 0.135 grams divided by 0.1 liter and get back to our units of gram per liter. So you could do it either way. Before we go on to percentages, I would recommend that there is a worksheet called Conversion Factor Worksheet that is found in the folder. It's not one that I'm collecting, but it's a really good practice for doing some conversion factors, and you should also be able to find the answer in the answer key for that worksheet. But this would be a good time to practice some of those problems. Well, let's just move on. Just a few other things to touch on. Percentages. This is probably a review for you, but let's just talk about what percentage means. Well, percent literally means per 100. So a percent is just the number of items in a group of 100 such items. So in order to calculate a percentage, we always use this equation. We take the part divided by the total times 100. So if I said that if I had a room of people and I said 35% of the people were male, what I would mean is out of every 100, 35 were male. So it doesn't always necessarily mean that I have to have 100 people, but if I did have 100 people, 35 of them would be male. If I wanted to figure out what the percentage was, let's say I had a room of 10 people and 3 of them were male. Then I would take the part that was male, 3, divided by the total, 10, times 100%, and that would give me 30%. 30% of the room is male. If I had 21 people and 5 of them were male, then I would take the 5 divided by the 21 times 100 would give me about 24%. So part divided by the total times 100. Okay, so here's another example. If you read a label, a person finds that the amount of fat contained in one serving of potato chips is 18.2 grams of fat. If the complete serving of potato chips is a total of 50 grams, what is the percentage of fat in one serving? Well, the part that is only fat is 18.2 grams. The total, the whole is 50 grams, so 18.2 divided by 50 gives me 36.4% fat. Okay, so like I said a minute ago, you can always think of a percent like a proportion. So if you have a percentage, that just means how many out of 100. It doesn't necessarily mean you have 100, but it just tells you how many out of 100. So it's always the part divided by the total. So to solve this kind of problem, you can cross multiply, or you can take the percent and multiply by the total to get the part. So for example, athletes can have as little as 3% body fat. If an athlete weighs 45 kilograms, how much body fat does that person have? Well, 3% body fat means 3 kilograms out of 100 kilograms, 3 out of 100. But this person doesn't weigh 100, this person weighs 45. So we want to know what is the portion out of 45 that is equal to 3 out of 100. So you can take the 3 divided by 100 and then multiply it by 45 to get 1.4 kilogram of fat. So if you want to go back and check yourself, 1.4 divided by 45 will give you 3%, times 100 will give you 3%. All right, just one more little topic, density. I had mentioned that a little bit earlier. Well, let's just talk about that for another minute. Density is a little bit different from mass. The density is actually a ratio of the mass of a sample divided by the volume of a sample. So, for example, if I said I have a pound of feathers and I have a pound of lead, which one weighs more? Well, because I said a pound of each, they would be the same. They would weigh the same. But if I said which one has a smaller amount, a pound of, takes up the least amount of space, a pound of feathers or a pound of lead, hopefully you would say a pound of lead. I could probably fit a pound of lead in my hand, whereas a pound of feathers I might need to have a whole bag full or something like that. And that's because feathers are less dense than lead. So they have per unit volume. So if I had the same volume of feathers and lead, the lead would definitely weigh more. If I took a cup of lead and a cup of feathers, the lead would definitely weigh more because it is more dense. Density is a physical property. It describes a particular substance. Water is actually defined as having a density of 1 gram per milliliter. And so if something is more dense than water, it should be greater than 1 and it'll sink. If something is less dense than water, it will be less than 1 and it will float. Here's an example of finding the density. So let's say I have a 20 ml sample and I put it into a container and I weighed it and I found that it has a mass of 24.4 grams. So what is the density? Well, since density is mass divided by volume, I take the mass, 24.4 grams, divided by the volume, 20 milliliters, and I get a density of 1.2 grams per milliliter. This would be something that was a little bit more dense than water, and so it should sink to the bottom. Densities for liquids are often reported in grams per milliliter. That's sort of the standard unit. Sometimes you'll see solids reported as grams per centimeter cubed. Well, a centimeter cubed is actually the same as a milliliter. It's just a different way of reporting it because solids have length and width and height, whereas liquids don't. Just as a little aside, centimeters cubed means if you had a cube that was a centimeter long times a centimeter wide times a centimeter high, that would be a cubic centimeter. And so sometimes people will write that as cc, cubic centimeter. So you may have heard of the unit, a cc of something. Well, that's exactly the same as a cubic centimeter and exactly the same as a milliliter. Just something to know for the future. Oftentimes gases are reported as grams per liter because they're so light, so you need a whole lot more of them to register a weight. One thing that's really nice is that density can be used as a conversion factor because now we know how many grams are equal to 1 milliliter. So if in this case a density of 1.2 grams per milliliter means that for every 1 milliliter of this liquid it will weigh 1.2 grams. So that's a conversion factor between grams and milliliters. And you can always use the unit that you want to find on the top and the unit that you're trying to get rid of on the bottom. If you're trying to convert from grams to milliliters, you would have grams on the bottom, milliliters on top. If you were trying to convert from milliliters to grams, then you would have grams on the top, milliliters on the bottom. There's also another way to use this equation. As long as you know 2 out of the 3 values, you can always find the missing one. So density is defined as mass divided by volume. Remember that mass is always the thing in grams. Volume is in milliliters or liters. So if you know the density and the volume, you can find the mass. Mass equals density times volume. And then volume equals mass divided by density. So let's look at this example. Calculate the volume in milliliters of 125 grams of chloroform, which has a density of 1.49 grams per milliliter. Well, if we're looking for the volume, we can use that third equation. Volume equals mass divided by density. So 125 grams divided by 1.49 grams per mil gives me an answer of 83.9 milliliters. The grams will cancel and my units will end up being milliliters.